Okay, today we're going to be doing the remainder and factor theorems. Notice what it says. The standard says know and apply the remainder theorem for a polynomial p of x and a number a. The remainder on division by x minus a is p of a. So if p of a equals 0, if and only if x minus a is a factor. And so we'll get to that part here in just a moment. The factoring part, remainder part. What it says is this: when I have a polynomial and I divide it by x minus k, then the remainder is going to be f of k. It's the same as if I substituted in with direct substitution, and the answer I got would be the remainder of when dividing by x minus k. Okay, here's an example. I have this, and I'm going to set it up like synthetic substitution is what we called it before, but now we call it synthetic division. So I'm going to put all of my numerical coefficients here. Be sure you remember that if you have one of these terms missing, that you need to put a 0 in. And then in the corner, because it's x minus k, if you recall on the other slide, I just put this portion in, so I don't look at the minus sign. The minus sign is right here. So I put 3 in the corner. And then I bring down the first number. I multiply, add, multiply, add, multiply, and then add. And negative 5 is the remainder. And truly, that's, if I were to divide this out, negative 5 would be my remainder. The factor theorem says that if I have a remainder of 0, which I did not have here, I had a remainder of negative 5, but if I have a remainder of 0, then I can factor out the rest of the polynomial. And we'll use synthetic division to determine what our remainder is. Okay, so let's do this problem. We're wanting to see if x plus 4 is a factor. Remember, it's x minus k, and the only way I'm going to get plus 4 is if I do x minus negative 4. So that's why I put negative 4 in the corner here. So if you want to just remember, you do the opposite of whatever this is, put that there, then you'll be okay. I'm going to write out all my numerical coefficients, which are right here. And then I do synthetic division, bring down the first number, multiply, add all the way across. I have some number other than 0, so no, this is not a factor. I have a remainder. I don't have a remainder of 0, so the answer is no. This is not a factor of that polynomial. So now we're gonna continue on, and this one is saying not only is it a factor, but once I do this, I need to factor the polynomial completely. So here's my polynomial. I'm putting down 2, negative 11, 3, and 36. And then I want to check and see if x minus 3 is a factor. Remember, we do the opposite of this. So we put 3 here. We're going to bring down the first number, multiply, add all the way across, and I'm not going to go into that very slowly here because you can see that math and you know by now how to do it. I do get a remainder of 0. That means that x minus 3 is a factor of this polynomial. And from another slide where we did synthetic division, you know that this coincides to the numerical coefficients that we bring down and we make right here. And this is 2x squared minus 5x minus 12. Now, I'm going to take that and I'm going to factor it to get my other two factors. So, and we've already done that in another unit, remember. So 2 times negative 12, negative 24. Put negative 5 here. We're looking for factors of 24, which subtract to be 5. So we put 8 and 3. And to get negative 5, we need negative 8. And so because we multiplied by 2, we're going to divide by 2. That gives me negative 4 and 3 over 2. And remember, my first factor is x minus 4. My next one is 2x plus 3. And then x minus 3 was given to me in the problem. So here we are. We have now factored this polynomial that we started out with completely down. We have factored it. Okay? And again, we're doing that again. We're going to see first off if this is a factor. We put negative 2 in the corner. We put down all of our numerical coefficients, remembering that if we have a missing term, we write a 0. We bring down the first number, we multiply, add all the way. We get a 0 on the end. So yes, x plus 2 is a factor. Then we write this out, 3x squared plus 2x minus 1. We multiply these two, we get negative 3. We want factors of 3 that subtract to be 2. That would be 3 and negative 1 when you put them together. 3 and negative 1 gives me negative 3 when multiplying, but when I add, I get a positive 2. So, and then remember, we have to divide by the 3 as well. So that gives me x plus 2, which was in the problem. And then x plus 1, and then 3x minus 1. So I have factored this one completely. All right, now, this says find the other zeros when you're given that f of negative 1 is a 0. Now, this is different from what we just did. When we're given a factor, we write the opposite in the corner. Notice that. Every time I've been given a factor, I write the opposite of what I see in the corner. Now I'm not given a factor, I'm given a 0 and asked to find the other zeros. So when I'm given a 0, you don't change it. So I write negative 1 here. That means that my factor is x plus 1. So just remember that. All right, so we're going to write down our numerical coefficients, and here they are. We're going to do the synthetic division, bring down the first number, multiply, add all the way across. That gives me 0 here. Then I'm going to take this polynomial and factor it. Now, I don't need to multiply here because this has numerical coefficient of 1. So I put negative 18 and 3. Factors of 18, which subtract to 3, are 6 and negative 3. We're going to use those. Then we factor it all out. Now, we already have the x plus 1. So I write it down. I write x plus 6, x minus 3. And our zeros, remember, are opposite of the factors. So my zeros are negative 1, negative 6, and 3. Here's another example doing the same thing. Remember, if it says zeros, you put the 2 in the corner, and you do your synthetic division. I'm trying not to make my video too long. All right, then I have, and I'll let you see it for a minute. Then I have x squared minus 2x minus 15. Here are the factors that we get. That gives me, all right, now we had x minus 2. Now I've got x minus 5 and x plus 3, and my zeros are 2, 5, and negative 3. Remember, you get your zeros by setting each of those equal to 0 and solving. And remember the shortcut that we learned early on in the year where it's just the opposite sign. Thank you.